Hello guys, so welcome to the third video of this ML bootcamp. In this video we are going to make our Snapchat filter project with the help of the opencv. So I have downloaded some images from the internet. This is of the cigar, glass and mustache that we are going to use in this project. And this is the face.xml file. This is the same face.xml file that we used in our previous video, that is Haar Cascade frontal face. I renamed it. And at the end of the video I will provide you this link by the help of which you can download all these Haar Cascade files. So I can give you one example. We are using this Haar Cascade frontal face this time. So you can use many of these Haar Cascade files. Suppose if you want to use Haar Cascade smile file, so it will help you to detect that person is smiling or not. So there is one more file is of Haar Cascade upper body. If you want to check that how many upper body of a person in this images, so then you can help to detect this. Now let's move to our editor. So in this we are using the PyCharm. Generally we use the PyTorch, but for the project purpose we are using this PyCharm. Now this video is going to be in the three part. So first of all we are going to see that how can we use our computer camera. In this we are naming it like capture.py. In the next part we are going to see our face detection part, and at the end we will see our Snapchat filter. So first of all we have to import cv2. After importing the cv2 we have to do capture equals to cv2 dot video capture. So we are passing the parameter 0 here because 0 is the position of the camera according to our computer, according to our laptop, any of the thing that you are using. Suppose if you are using some of the external PC camera or external hardware camera, so then you have to pass its location over there. Instead of 0 it may be like 1 2 3 1, anything that is mentioned by the particular camera that you are going to use. Now if the capture is open, then we have to do, if while the capture is open, what I want to do, I want to read the frames of that particular camera, that what is that camera is showing to us. So I will do result comma frame equals to cap.read. So this cap.read returns two values. So first value is of result and other is frame. That frame is that particular frame that camera is going to return, and result is going to tell you that the value is coming or not. So result is a boolean value and frame is a particular numpy array that we get from that camera. After that, if result is true, it means that a value is coming. Then what we want to do, we want to show it. So I want to show that particular camera, so I will name it like frame and do frame. And after that, now we have shown the frame, but now what will happen if we want to off the frame, like our work is done and I want to close that. So we have to do if cv2 dot wait key, cv2 dot wait key, let's pass the 5 seconds over there. Order will pass q and we will break. After our work is done, I want to do cap.release. So it means that I do not want to store my value in our cache, and I want to destroy all the windows that we use that we use by the help of that camera. So I will do destroy all windows. So basically the question sometimes people ask me like that in the video capture part, why we are passing 0, not like other values. So okay, now let's go to our console. So I will now give it some print also, like print, I want to print result, and I also want to print our frame. So now let's run our code and see that what are the different outcomes will come when we change our values. But this is the basic and a very good code that will going to run in everyone's PC. So we have to use this code. Okay, now after that I will going to show you that what is going to happen if we change the value. So now you can see I press Q and the code is stopped. So now you can see that the result is coming true and this is our frame. The result is true, and this is going to have a frame, and that is a continuous loop that is running again and again. So now if I do not want to print this, what will happen if 1? So that 1 is, there is no external camera here. If I pass 1 here and I do this, then you can show that no screen will appear. It will showing you black screen, and because the 1 is not going to take any camera, and I press Q, our screen is going to be closed. Now we are going to do our face detection part. So for this, let's make a new file. So for the face detection part, we already want that general code. After that, we are going to use our face detection part in it. So I will copy this code and paste it into face detection file. Now I want to detect our face. So first of all, I want a cascade classifier to be imported in that particular file. So I will name it like cascade. Cascade equals to cv2 dot cascade classifier, and I want face dot xml file. That is the Har cascade frontal face, and after that Har cascade frontal face, if the result is true, we are getting our capture. So what we want to do, like we want to detect our face, so we will do gray equals to cv2 dot cvt color. I want to change the color of the frame to cv2 dot color bg to gray. So why we have converted this frame into gray color? Because the cascade classifier will work and better in this gray color situation. Now I want to detect the frame. I want to detect our face in this gray screen. So we will do faces equals to cascade dot detect multi-scale, and I want to pass gray. And if you want to know more feature of this, like there it will take scale factor, minimum neighbors, minimum size and the maximum size. So let's take the scale factor equals to 1.3, and is any after scale factor there is minimum neighbors. So let's take 5, and that is 0, and that is we pass 0. Our flag is going to be 0, then our minimum size is going to be, I think, 120. Yeah, let's take it 120 comma 120. That is going to take a tuple value, and after that max size is going to be our, let's 350 comma 350. Yeah, okay. So if we detected the face, now I simply want to show a rectangular box on my particular face. If we detect a face, I want to show a rectangular box by which we can able to see our face, that a particular that a Har cascade file is working properly and it is going to detect our face or not. So for that we will do, for the faces are going to return a array with the 4 values that are x comma y comma w comma and height. So in the faces, what do I want? I want to generate a rectangular box. So what I will do, cv2 dot rectangle, and I want to generate a rectangle on the frame. So I will pass for the xy, that is going to be our starting point of the rectangle, and I want a one more diagonal point of the rectangle. So I will pass x plus w, and other point is going to be our y plus h. Yeah. So and I want it to be 255, 0 and 0. That is the color of that particular rectangle, and let's pass this to thickness. So now let's check that everything is going to work fine or not. So for this, now let's run the code. Okay, that is creating a problem. Oh yeah. The problem is that I passed 1 over there. I want it to be 0, and the capture.py also we want 0 because there is no camera at the position 1. Okay, now everything I think should work fine. Yeah, so it is working fine. So my face is getting detected. So this is the rectangular box. You can also change the configuration of it. So suppose I do not want like blue color, I want any other color. So it will, I think, show you some other color. It is showing green. Okay, so it is like BGR format. You can generate a box according to you want. Suppose if you want to pass the 5, that will provide you the thickness of that rectangular box. You can generate and you can do the face detection. Okay, so it is working fine. Har cascade is not a very good suggestion, is not a very good thing. So I will suggest you that you can use a dlib. There is one more library in Python, dlib, that provides you fake recognition, and that will work far more better. So you can use it. Now let's move to our Snapchat filter part. So this is the last part of that video, and we are going to see that how we are going to put mustache and our glasses and our cigarette on that particular face. Now guys, we are going to make our snap.py file, but before making this file we have to understand one concept. So let's move to one notebook. As we do our face detection part, we have generated a rectangle. So there was one thing in it like xy coordinate and w coordinate and y plus h coordinate. Let's understand this. So suppose this is my opencv full screen. This is my full screen and this is my face. That is a detected face in this particular rectangle. So this is going to be my x and this is going to be my y. So this coordinate is represented as xy. Let's talk about this coordinate. If we got these two coordinates, we will be able to generate a rectangle. So suppose this is going to be my width and this is going to be my height. So this coordinate is x plus w and y plus h. So we give these two coordinates to our OpenCV and detect our face and generate our rectangle. So now let's see what happens if we want to suppose generate our glass. So if I want to put a glass on this rectangle, so what is the configuration? Suppose let's see some configuration in our face. Like this is my face, this completely square is representing my face. So suppose let's imagine that my eyes are going to be like 2 points away from my head. Like my lips are going to be like 5 points away from my head. So these are there are some of the concept, and there is some configuration in which our eyes, our lips, our nose are perfectly configured. So we are going to use these two concepts like our face detection part and this configuration part. So you will now able to see when I do code now. Let's move to our code part. So we need this face detection part. So first of all, let's copy this in our snap.py file. I want to do specs orientation equals to cv2.imread, and I will read our glass.png, and I will give it -1, and I want our which file? I want our cigar png and mustache. So I will do okay. So let's copy paste it also, and I want our cigar and our mustache. So we have taken all the file in our code. Now let's move forward. This time we do not want this rectangle part in that snap.py file. We have understand it concept. So now let's move forward. Now I want to do what? I mostly, first of all, I want to put our glasses, then my cigar, and then my mustache at a particular configuration in my face. So if height is going to be greater than 0 and width is going to be greater than 0, if we determine our face and there is some sort of height and width, then we are going to put our glass, cigar and mustache. So first of all, for the glass, So what I have done, so I have generated two values for the glass, the Simon and the Simex. So suppose, let's understand this also. So this is my face. If this is going to be my glass, so this value, this particular full value is going to be my max value, and this minimum value is going to be my minimum value from the y. So this at this particular space is going to be my SH glass. This is the difference. For the same we have to do for the cigar, and same we have to do for the mustache. So we are going to generate now. Let's copy paste this and copy paste this. So now I want to do for the cigar and for the mustache. Cigar. Now take the maximum value for the cigar, and now I want to change the configuration also. So its configuration is going to be, I think, 4 and h by 6, and this is, I think, 5.5 and h by 6, and for the mustache it is 3.5 h by 6, and this is going to be 5. So these are the configuration of the mustaches, and let's change the value also. SH, it is SH cigar, this is going to be mustache. Okay, and this is also going to be mustache. Mustache. Anything else left? Oh yeah, we're not changing the value for the cigar. So our minimum and maximum work is done. We have generated all the configuration for the glasses, cigar and the mustache. Now we are going to generate our orientation. We want to put all these images on our particular screen. So we want this particular space to be removed from our frame. So we want this orientation to be put on that particular frame. Face, glass. Orientation equals to frame, glass, Simon, glass, Simex. So these are my Simon and the Simex, and this time we will take our x colon x plus w. So these are our width. So this is the face glass orientation. Let's understand with the help of the notebook. So if we see it, this is my face and this is my glass. Suppose this is my particular glass. This is my minimum value. This is my max value. So this is my Simon. This is my Simex. So suppose if we are putting our glasses on the particularly this full rectangle, so what is the width of it? Then the width is going to be like started from the x and going to up to x plus w. So that is what we are generating by the help of it. Same for our cigar and the mustache also. This time we will do our part for the cigar and the mustache. We will do, first of all, I want for the glasses we have done, I want for the cigar, and I want for the mustache. And this is going to be for our cigar, and this is going to be for our mustache. So we have also generated our. Okay, so what we are going to do, I want to specs This is going to be my glass. Okay, let's put it name equals to glass only. Glass equals to cv2 dot resize. I want to do resize it. So what I want to resize our specs orientation. This is going to be my spec orientation. This is the thing that we have read. This is my glass image. So I want to resize it. So specs orientation with, we are going to resize it with w comma our sh glass. So these are the our difference, and this is going to be our width, and interpolation is going to be our cv2 dot intercubic. Yeah. So we have to do all the 3 steps for our cigar and for our mustache. This is going to be our cigar and this is going to be our mustache. Okay, let's do it for cigar. And let's do it for our mustache. So now we have do the interpolation for the glass, cigar and the mustache. We have taken the orientation, we have taken our minimum and the maximum. So now understand the concept. So suppose this is going to be my detection part, phase detection part. So I want to put our glasses over there and our mustache over there. Our the pixels that are of the frame. So let the pixels of the frame be 0 and all the pixels of the glass should be represent on our frame. So these are the pixels of the glass. Okay, so we are going to transparent our frame, a particular location of a frame, and we will put all the pixels of the particular glass, cigar and the mustache over it. So this is the concept we are going to use. So let's generate our function. Transparent overlay. So first of all, I want to plus the phase glass orientation. I want this thing and I want our glass. So I want going to replace this phase glass orientation with this glass. Okay, so now let's generate our function. So let's define transparent overlay. So we have taken the source and we have taken the overlay image. That is going to be our source, is going to be our face glass and glasses. Okay, this is our overlay. These are the 2 things that we have required in it. So first of all, I want to pass the overlay equals to cv2, and this again we are going to do the resize, and we'll pass the overlay comma 0 comma 0, and we have to pass the fx equals to scale and fy equals to scale. Okay, the scale value of the scale is to be 1, so let's pass it in a function only. Scale is going to be our 1. Let's say height and w, we are going to take like overlay dot shape, into overlay dot shape. After that, what I want to do, I want to do rows and columns equals to source dot shape. So I will mention some comments also. This is the size of background image. This is our size of foreground image. Okay, so these we have generated. Now what I want to do, this is the our y. Let's take the y and x axis position also. Y comma x equals to position 0 comma position 1. So let's determine one more here. Position equals to 0 comma 0 for I in range h, and for j in range w. If x plus I greater than row 2, then rows of y plus j is greater than equals to columns. So continue. Other than that, I want to the float variable, I want to overlay this may I j and all the 3 pixels. I want to, this concept is known as the read the alpha channel. We have generated a 2 for loop. In the first for loop, this for loop are working on our foreground image. So first of all, we are taking our foreground image, so it has its width and it has its height. So when we generate our foreground image, when this image is going beyond our background image, suppose it is bigger than that, so we will neglect that part with the help of this if condition. So we do continue in this part. We do not want to do anything. We want our background image as it is. But if it is in our condition that it is between our background image, so what we have generated our alpha channel. Okay. And now what I want to do, I want to delete all the pixels that are coming from the background images, and I want to put my foreground image on that. So for this I will do source equals to x plus I, y plus j, and this is going to my point where I want to change my pixel. I will do alpha plus overlay. I want to do particularly pixel over this. Now I want to do 1 minus alpha into source x plus I and the y plus j. And after that we have generated this thing. We want to do, I want to return my source. Oh, why it is giving me an error? Okay, so this is an error. I've put the name rows. So I've generated, our function, and I hope that everything should work fine. Let's check it. I missed something. I have missed. I do not put okay ing over there. This is some problem. I hope it is now work fine. So okay, that is giving me one more error. Let's check. It is HW. Okay, I got the error. It is a 3D image, so I have to pass that, like give it like underscore. I can give it here. Yeah. And the same error will come in this also. So I have to do this. Now I think it will, work fine. Everything should looking good. Now let's check. So cool. Okay, now let's move and put our mustache and then our cigar. Okay, for now we have to do our transparent overlay. We have to pass our Okay, so now if I run it, okay, it is showing me again, there is some sort of error. I have done it. So I figure it out. I have mistype here also. I will do this mustache, and now everything should work fine. So yeah, so I got the mustache also. So I think these both are looking cool. Generated our our glasses and mustache, and I'm leaving this cigarette part for you. You can put our cigarette over there. So if you want to put our cigar, so what we have to do, we have to put our cigar at our position of, like, this thing is perfectly fine. Our orientation, our position is going to be 0, 0 for our glasses and mustaches. For our cigarette, our position is going to be, our position is going to change. So our position is going to be now, this position is going to be like from the top to bottom, it is going to be perfect. From like position from our width is going to be at the center. So for the position you have to pass our width by 2 and our cigar by 2. So I hope you can try it at the home, and something can explore more by the help of the Harkasket files. And this is all for it. From the next video we are going to start our machine learning part, and in the next video we are going to cover our topic of our machine learning linear regression. Bye bye.